Welcome to the Bite-Sized Tech News TLDR podcast. If you are joining us right now, go ahead and pull up a chair, get comfortable, and just imagine it's the three of us sitting in a room together, you, me, and our resident expert, about to tackle some news that is genuinely, it is shifting the ground right beneath our feet.
It really is. It's good to be here.
Yeah, it's great to have you. Because we do this, right? We do this because the world of tech moves just relentlessly. And sometimes you just need to pause, look directly at the source material, and figure out what is actually happening behind the constant stream of headlines.
Exactly. You have to cut through the noise.
Right. And to mirror our YouTube channel's goal of turning complex news into digestible summaries, we are keeping the energy high and the pace fast today. We are zeroing in on a single, highly impactful source. We're pulling directly from a transcript of a video we uploaded titled, Introducing GPT-5.3-Codex, the Frontier Agentic Coding Model.
A very heavy title for a very heavy release.
For sure. And we're dedicating an entire deep dive to this specific breakdown because it perfectly encapsulates a massive leap in AI that OpenAI dropped on the world on February 5, 2026. We are, of course, talking about GPT-5.3-Codex.
Right.
Now, I know what you might be thinking listening to this. If you aren't an engineer, your eyes might immediately glaze over the second you hear the word codex.
Oh, absolutely. It sounds like terminal code.
Exactly.
Yeah.
You might think this is an insular update for the guys writing Python scripts in dark basements. But I promise you, by the end of this deep dive, you will see exactly why this specific release affects you, regardless of what industry you work in.
Yeah, it's universal.
Our mission today is to explore how this isn't just a shiny new upgrade to a coding autocomplete tool. We are looking at the raw bottom line. What are the real-world implications, and what is the immediate productivity impact for the average professional?
That's right. And the shift we're really talking about here boils down to a core thesis that we'll trace throughout this entire discussion. For the last several decades, straight through the recent generative AI boom, we've fundamentally viewed software as a tool.
Just a tool.
Right, and a tool is inert. A tool requires a human to wield it, to direct it, to provide the continuous energy and intent for it to do anything useful.
Like a hammer.
Exactly like a hammer. A hammer doesn't frame a house, it just sits in a toolbox waiting for a carpenter to swing it. But what we're witnessing with the release of 5.3 Codex, as heavily emphasized in the video transcript, is the definitive transition from computers as passive tools to computers as active agentic collaborators.
Agentic collaborators.
Yes, and this isn't just marketing speak, it's a very precise terminology shift. An agent possesses autonomy. It maintains long-term context, it actively pursues goals, and critically, it initiates action without needing you to press a button first.
It does things on its own.
Right. We're moving out of the era of dictation and prompt engineering and stepping into an era of true digital partnership.
Okay, let's unpack this. Because the word agentic gets thrown around a lot in tech circles right now, often just to make a standard chatbot sound a lot fancier than it actually is.
Oh, constantly. Everything is an agent now.
Exactly. But the source material really nails down what this means in a strictly practical, operational sense. The transcript highlights a quote from OpenAI that sets the stage perfectly. They say, "We're not talking about a tool that just does what you tell it to do anymore."
That's the crux of it.
Yeah. The ultimate goal here is a true agent. And to illustrate what that actually looks like on the ground, the source lays out a hypothetical workflow that I think we really need to visualize to understand the magnitude of this shift.
Let's hear it.
Let's look at the old paradigm first. Say it's 2024 or 2025. You have an AI coding assistant. You tell it to build a new feature for your app. Let's say a new checkout flow.
Standard request.
Right. It generates the React components, it spits out the code, and its job is entirely done. It goes dormant. It has literally no idea if that checkout flow actually works in the wild, if users like it, or if it's actually converting sales.
It's blind to the outcome.
Completely blind.
Yeah.
But this new 5.3 Codex model operates on an entirely different plane. You ask it to build the feature, and it does. But then it actively hooks into your telemetry. It watches how your human users are interacting with that specific checkout flow.
It's observing.
Yes.
Yeah.
It analyzes the event data, looks at the drop-off rates, and then it comes back to you completely unprompted with an insight. It says, hey, I noticed a 15% drop-off on mobile devices when users hit the billing zip code field. I've designed a frictionless Apple Pay integration to bypass this. Want me to push it to staging?
What's fascinating here is the sheer amount of cognitive overhead that this dynamic transfers from the human operator directly to the machine. Let's really break down what a human product manager actually does in that scenario you just described.
They do a lot more than just write code.
Exactly. They aren't just executing discrete, isolated tasks. A good PM is maintaining a persistent, high-fidelity mental model of the product architecture, the user base's behavioral psychology, and the overarching business metrics.
Right. They hold the whole picture in their head.
And for an AI to execute that loop, building the feature, observing the behavioral data, analyzing the friction points, and synthesizing a proactive suggestion, it requires an immense amount of sustained context. It requires durable memory.
It has to remember why it built the thing in the first place.
Yes, and most importantly, it requires the initiative to recognize a pattern that the human might have completely missed and to formulate a solution independently. That is the defining characteristic of an agent. It's no longer a sterile command and response dynamic.
It's a continuous closed loop of value creation.
Precisely. When you tell a traditional LLM to write a script, it assumes your command is flawless, comprehensive, and final. An agentic collaborator, on the other hand, assumes your command is just the opening salvo of a much longer, iterative conversation.
I want to push back on that slightly, though. You're describing it as this highly autonomous entity, but doesn't that inherently reduce the human's control?
How so?
Well, if I'm a developer or a founder, the idea of an AI unilaterally deciding what feature to build next based on its own interpretation of analytics sounds a bit like I'm surrendering the steering wheel. Does the source material address that friction? Because handing over the keys to the product roadmap seems like a massive leap of faith.
That's a vital distinction to make, and the source material actually addresses it head-on by emphasizing the interactive nature of this new workflow. The transcript explicitly points out that we are shifting away from the old paradigm of giving orders, but we aren't moving to a paradigm where the human is obsolete.
So we aren't just letting it run wild.
No, not at all. It describes a process that is fully interactive and happening in real time. You aren't just throwing a massive finalized spec document over a brick wall and hoping the right code comes back a week later. You remain absolutely in the driver's seat.
Okay, that's reassuring.
What you have now is a highly competent, tireless co-pilot. You have the ability to continuously steer the ship while the AI is in the middle of tackling these massive, complicated jobs.
I mean, you can interrupt it.
Exactly. The video mentions that while the AI is generating an architecture or refactoring a massive database, you can literally interject midstream and say, hey, maybe try this instead. I don't like how this specific service is decoupled.
It just listened.
It pivots effortlessly. It maintains all the previous context, but adjusts its trajectory based on your intuition. It's a partner for the whole process, not a black box that shuts you out.
So it's less about the AI taking over and more about exposing its thought process so you can course correct on the fly. But let me ask you about the mechanics of that. Why is this real-time interactive steering so crucial for complex problem solving?
That's a great question.
Because why couldn't we just get better at writing those massive detailed prompts for the older models? If I just spent 3 hours writing a perfect prompt, couldn't a 2025 model achieve the same result without needing me to micromanage it?
The short answer is no. And the reason lies in the inherent nature of complex problem solving itself. Software engineering, system architecture, or really any advanced professional endeavor is almost never a straight line.
It's messy.
It's inherently exploratory. When you try to write a highly detailed monolithic prompt for a traditional AI, you're operating under the false assumption that you know exactly what the final outcome should look like and exactly what hidden constraints will emerge along the way.
Which you never do.
Never. In reality, the moment you start building a complex system, you uncover unknowns. You realize a specific database schema won't scale the way you thought, or an API rate limit creates a bottleneck you didn't anticipate, or a user interface element simply feels clunky once it's actually rendered on a screen.
You can't prompt your way out of unknowns you haven't encountered yet.
Exactly. By allowing real-time interactive steering, GPT-5.3-Codex allows the human to inject their hard-earned intuition, their domain expertise, and their judgment dynamically as the solution takes shape.
That makes total sense.
If the AI starts going down an architectural rabbit hole that the human engineer knows from experience is a dead end, the human doesn't have to wait for the AI to finish, fail, and then start over. They can gently course correct with that, hey, maybe try this instead. Input.
Catching the mistake early.
Right. It prevents the AI from wasting computational resources, generating a flawless execution of the wrong idea. It keeps the human deeply integrated in a loop of continuous alignment, which frankly, is exactly how elite human engineering teams operate when they're whiteboarding a problem together.
It's the difference between handing a contractor a blueprint and leaving the country for a month versus being on the job site every day saying, actually, let's move that wall a few inches to the left before you pour the concrete.
That's a perfect analogy.
You catch the errors when they're cheap to fix, not after the system is fully compiled. But for that on-the-fly collaboration to actually work, for it to not be incredibly frustrating, there's a physical limitation that had to be overcome.
The speed.
Exactly. The source transcript highlights a very specific performance metric that might seem dry at first glance, but they emphasize it heavily. It states that GPT-5.3-Codex is 25% faster than previous iterations.
Which is a huge deal.
But is it? Because if my web browser loads a page 25% faster, I'm probably not even going to notice. But the folks at the Bite Size are incredibly emphatic that this speed increase is absolutely crucial to the whole agentic paradigm working. Yeah. Why is a 25% bump in speed the linchpin here?
Because in the context of human-computer interaction, a 25% increase in a frontier large language model's inference speed isn't merely a technical specification to put on a slide deck. It is the crossing of a psychological threshold.
The psychological threshold.
Yes. We have to view this through the lens of cognitive friction. When a human professional is engaged in deep, complex work, what psychologists refer to as a flow state, their brain is operating at a very specific, delicate rhythm. They're holding a massive amount of abstract variables in their working memory.
Right, you're in the zone.
You're in the zone. And if you're collaborating with an entity, whether that's a junior developer sitting next to you or an AI agent on your screen, and there's a noticeable lag between your instruction and their response, that latency introduces friction.
It breaks stealth.
It actively breaks your flow state. If you have to wait even 10 or 15 seconds for an AI to generate the next logical block of code or to analyze a data structure you just handed it, your mind starts to wander. You lose the thread of your complex mental model.
You check your email, you look at your phone.
And the context is gone. The 25% speed increase pushes the model's response time below the threshold where the human brain perceives it as waiting.
Sitting around waiting for it to catch up is exactly the phrasing the video used to describe the old way of doing things. They say this new, faster speed makes the back-and-forth communication feel totally smooth and natural. They describe it as working side by side at the speed you think.
At the speed you think.
That specific phrase is heavy. If the AI can instantly pivot the moment you suggest a new direction, you're essentially experiencing frictionless creation. You're no longer managing the latency of the tool, you're just manipulating the raw ideas directly.
It changes the entire relationship with the machine.
It brings to mind the transition from punch cards to compilers in the early days of computing. When programmers had to wait 24 hours to see if their punch cards compiled, they programmed one way. When they got instant feedback on a terminal, the entire software industry exploded because the iteration cycle tightened to match human thought.
That's exactly what's happening here.
This feels like the exact same leap, just applied to high-level system architecture instead of basic syntax. So what does this all mean? We've talked extensively about the theory, the defining traits of an agent, the necessity of interactive workflows, and the psychological impact of crossing that speed threshold.
But we need to look at the hard numbers.
Right. Because the bite size didn't just deal in theory. They made sure to ground this in concrete, undeniable proof. They explicitly say this isn't just some abstract improvement that looks good on an OpenAI research paper. We're looking at hard performance gains.
Let's talk about the benchmarks.
Let's dig into the specific benchmark they highlighted, Terminal Bench 2.0. According to the source, this is a rigorous test of how well an AI can handle the command line.
Yes.
The previous flagship model scored a 64%. That sounds somewhat decent, maybe a D grade if we're using high school metrics. But GPT 5.3-Codex jumped all the way up to 77.3%.
That is a massive jump.
But for listeners out there who might work in finance or marketing or operations and who rarely, if ever, open the raw command line terminal on their operating system, can you unpack what this specific capability actually represents? Why is a 13.3% absolute jump in this specific area such a monumental leap in practical utility?
It's a monumental leap because the command line is the absolute bedrock of modern computing. It is the stark, unadorned text interface where you bypass all the graphical user interfaces and issue raw directives straight to the operating system's kernel.
It's the engine room.
Exactly. It's where the actual structural work of computing happens. There are no buttons, no helpful visual cues, no guardrails. It is pure, unforgiving syntax.
Right. If you type the wrong thing, bad things happen.
Very bad things. So when an AI model can navigate a command line environment effectively, it proves that it possesses a deep structural understanding of the computer's fundamental architecture. We're talking about the ability to move and structure file systems, modify core permissions, install complex software dependencies, configure web servers, and diagnose obscure network routing issues.
All the heavy lifting.
Right. Now, why does the jump from 64% to 77.3% matter so much? Because the command line is an environment with zero tolerance for error. If a model has a 64% success rate, it means it's helpful, but fundamentally unreliable.
You can't trust it.
No. In a command line environment, being wrong 36% of the time is disastrous. A hallucinated command might accidentally delete a crucial database directory or misconfigure a vital environment variable that takes down your entire application.
Ouch.
If you're a human developer using a 64% model, you have to constantly audit its work line by line, which completely defeats the purpose and ruins the flow state we were just discussing.
Right. If you have to spend 20 minutes debugging the AI's script to figure out why the server won't boot, you might as well have just written the bash script yourself.
Precisely. But jumping to a 77.3% success rate crosses a critical threshold of reliability. It moves the AI from being a risky liability to a trusted autonomous operator in the foundational layers of a system.
So it can actually do the unglamorous work.
Yes. A 13.3% improvement on Terminal Bench 2.0 represents a colossal leap in real-world utility because it means the AI can now be trusted to handle the tedious structural setup and configuration of a complex project. It can provision the servers, set up the containerization, and link the databases autonomously, freeing the human engineer to focus entirely on the high-level business logic and the creative architecture.
I see. It's the difference between having an assistant who hands you the nails versus an assistant who can independently frame the entire house, run the plumbing, and pass the inspection before you even arrive on site to pick out the paint colors.
That's it, exactly.
And the source actually provides a brilliant, tangible example of what this advanced capability looks like in practice, moving beyond just configuring servers. The transcript walks us through a scenario where a user asks the AI to build a simple landing page.
I love this example.
It's so good. They note that the old model, the 64% model, would give you an okay first draft. It would spit out the HTML, write some standard CSS, and give you a functional but static web page.
Very basic.
But GPT-5.3-Codex does something entirely different. The video explicitly says it just gets what you're trying to do. It points out two specific, highly revealing details about the AI's output. First, without being prompted, the AI knows to frame the yearly subscription price as a monthly discount to make it look more appealing. Second, instead of just slapping a boring static text block on the page for a customer testimonial, it proactively builds a dynamic, interactive carousel.
It's thinking about the user.
Exactly. It doesn't just deliver code, it delivers something polished, optimized, and ready for production right out of the box.
That landing page example is incredibly illuminating, and it's perhaps the most important anecdote in the entire source transcript, because it highlights the fundamental transition from mere syntax generation to deep semantic comprehension.
Semantic comprehension.
Yes. Let's look at the elements you mentioned. Writing the raw DOM manipulation code for a static text block versus a dynamic JavaScript carousel is one thing. That's just a syntax problem. But the AI making the proactive decision that a dynamic carousel is superior for user engagement in that specific section of the page.
That's not just coding.
No, that's an understanding of interaction design and user experience. Similarly, the pricing structure. The AI wasn't explicitly told to apply psychological pricing models, but it understood that framing an annual $120 fee as $10 a month billed annually dramatically increases conversion rates.
That's smart marketing.
That's marketing strategy. The AI is demonstrating that it understands the underlying intent behind the human's request. The human's literal prompt was likely something simple, like build a landing page for my sauce product.
But what they really meant was make me money.
Exactly. The unstated underlying intent was, I want a page that effectively converts casual visitors into paying subscribers. GPT-5.3 Codex recognizes that unstated intent and applies cross-disciplinary knowledge, synthesizing raw software engineering with marketing psychology and interaction designed to deliver a holistic solution.
It's bringing all these disciplines together.
It's proving that it's no longer just solving the coding problem, it's solving the business problem.
That's a profound distinction, solving the business problem. And that cross-disciplinary power leads perfectly into the next major revelation from the source. The transcript makes it abundantly clear that this paradigm shift is absolutely not confined to software engineers.
Not at all.
The actual name of the model has the word codex right there in the title, which implies a narrow focus. But the video explicitly states this isn't just for developers anymore. They run through a whole litany of diverse non-developer tasks that this AI is now handling effortlessly.
Let's hear the list.
Okay, so product managers are utilizing it to draft comprehensive product requirement documents, or PRDs. User researchers are using it to ingest and analyze massive data sets of qualitative customer feedback. It's being used to whip up executive slide decks, crunch complex financial models and spreadsheets, and even do high-level copy editing.
It's a generalist now.
But I'll be honest, when I first read that, I was highly skeptical. How does an architecture specifically trained to optimize Python or JavaScript execution suddenly become a domain expert at crafting a compelling narrative for a slide deck or structuring a strategic PRD? Are we just seeing an AI hallucinate confidence in areas it doesn't actually understand, or is there a genuine translation of skill happening here?
Your skepticism is entirely warranted, but the translation of skill is very real, and it points to a deeper truth about the nature of knowledge work. It happens because the fundamental cognitive mechanics required to manage any modern, complex project all boil down to manipulating logical structures to achieve a specific goal.
Okay, break that down for me.
Think about it abstractly. Code is essentially logic structured in a highly formalized syntax to achieve an outcome within a digital environment. A complex spreadsheet is logic structured to analyze and project quantitative data.
Right.
A slide deck is logic structured to communicate a persuasive narrative visually. A product requirement document is logic structured to align a disparate team around a unified feature set and timeline. The underlying cognitive muscles required to architect a robust, fault-tolerant software application are remarkably similar to the muscles required to architect a robust business strategy or a comprehensive research synthesis.
It's all just structuring logic.
Exactly. And as the AI became sophisticated enough to understand the high-level intent behind software, as we just discussed with the landing page's marketing intuition, that generalized reasoning capability spilled over. Once a model truly understands structure, causal relationships, narrative flow, and data manipulation at an elite level, applying those concepts to a PowerPoint file instead of a Python file is a trivial leap.
That makes a lot of sense, actually.
That's how a coding model organically evolves into a generalized professional collaborator.
It really is positioning itself as the complete team member. The transcript goes on to say that it spans the entire life cycle of a project. It can help with the initial ideation, the drafting, the debugging, writing the automated test, deploying the infrastructure, and writing the release copy.
The whole shebang.
The whole shebang. I really want you, the listener, to pause whatever you're doing for just a second and genuinely imagine your own daily workflow. Even if you don't know the first thing about coding,
Just picture it.
imagine having a persistent partner sitting next to you that can seamlessly transition from formatting a brutally complex financial model in Excel to drafting a perfectly calibrated, diplomatically toned email to your stakeholders explaining that model, to designing a visually stunning presentation based on that data, all operating at the speed of your own thoughts.
It's wild.
It completely shatters the traditional bottleneck of human productivity. In the current paradigm, you are limited by your tactile ability to operate the software, your proficiency with PowerPoint, your mastery of Excel formulas, your typing speed. In the agentic paradigm, you are solely limited by your ability to direct the overarching strategy.
And that frees you up to do what humans do best. Strategy.
Here's where it gets really interesting, though. We've talked extensively about what this AI can do for us, for the PMs, the marketers, the developers. But the source material from the bite size introduces what I consider to be the most mind-bending sci-fi element of this entire deep dive.
Oh, this is the best part.
It's not just about what the AI can do for human professionals. It's about what it did for itself. The transcript poses a very logical question. How on earth did OpenAI make such a massive, unprecedented jump in capability this fast?
A timeline was crazy.
And the answer they provide is that OpenAI utilized early, unreleased versions of this very model to help build the final version of itself.
Yes. We are looking directly at the tangible beginnings of recursive self-improvement. It is an AI feedback loop in real-time production.
It sounds like a movie.
It does, but the source doesn't just speak in vague terms about this either. It outlines the highly specific, deeply technical tasks that this AI coworker performed during its own creation process.
What exactly was it doing?
It states that the AI was actively watching and debugging its own training runs. It was working alongside human engineers to tune the system's hyperparameters. It was autonomously managing the GPUs.
The graphical processing units.
Right, the GPUs that provide the raw, massive computational horsepower required for frontier AI training. And perhaps most astonishingly, the transcript notes that it analyzed its own benchmark test results to identify where its reasoning was weak, and then proactively provided the human engineers with insights on how to alter its own fundamental architecture to fix those weaknesses.
Okay, I'm going to need you to go deep on this and break it down for us. Because phrases like managing GPUs and analyzing its own test results sound like something out of a cyberpunk novel. Let's start with the hardware. What does it actually mean on a practical infrastructural level for an AI to manage its own training hardware? Is it just acting like a glorified server load balancer?
It goes vastly deeper than standard load balancing. To grasp the magnitude of this, you have to understand the sheer scale of the infrastructure we're talking about.
It's massive.
Massive. Training a frontier model like GPT-5.3-Codex requires coordinating tens of thousands of high-performance GPUs across warehouse-scale data centers. These clusters draw astronomical amounts of power, they generate immense heat, and because of the scale, individual chips and network interconnects are constantly failing.
Just from the sheer stress on the system.
Right. Managing this infrastructure is arguably one of the most complex logistical and engineering challenges on the planet right now. Network bottlenecks severely throttle training time, memory constraints dictate model size, and the optimization of tensor data flow through these chips is an incredibly delicate, high-stakes science.
So it's not just plugging them in and turning them on.
Not at all. When the source says the AI manages GPUs, it means the AI is autonomously monitoring the health, thermal efficiency, and data pipelines of the very hardware cluster that is actively calculating its own neural weights.
Wow.
It's identifying micro inefficiencies in its own physical incubation chamber. It's dynamically writing and deploying scripts to optimize the temperature controls, route around failing node interconnects, and maximize the data throughput. It's squeezing every ounce of theoretical performance out of the silicon, a task that normally requires a team of highly specialized world-class DevOps engineers working around the clock.
So it's optimizing its own physical gestation. That is staggering. But then the source goes further and says it's analyzing its own test results. And I have to assume that's not just it looking at a spreadsheet and saying, hey, I got a B+ on the math test. What does architectural self-correction actually entail?
It represents a profound, almost eerie level of self-reflection. When a frontier model is being trained, it is continuously evaluated against massive suites of complex benchmarks. Logic puzzles, coding challenges, spatial reasoning tasks.
To see how smart it's getting.
Exactly. In the traditional paradigm, human AI researchers pore over these results. They scratch their heads, look at where the model failed, and try to theorize why. They ask, why didn't it understand this specific logic trap? Do we need to feed it more high-quality math data? Do we need to tweak the attention mechanism?
So it's a lot of human guesswork.
A ton of guesswork. What the source describes is the AI itself taking over that analytical workload. The AI looks at its own failures, traces the breakdown in its own reasoning pathways, and essentially tells the human engineers, I'm failing this class of logic puzzles because my context window isn't weighting the initial variables heavily enough during the final output generation.
It diagnosing its own brain.
Yes. It says, if you adjust the learning rate here or modify this specific architectural parameter, I will become structurally smarter. It is engaging in simultaneous infrastructural management and architectural self-correction. It's not just learning from data. It's redesigning the way its brain processes data.
It literally became a senior engineer on the project of its own creation. It's hard to even wrap your head around the compounding implications of that. And the pace of progress that results from this recursive feedback loop is exactly what you'd expect. Staggering.
Very much so.
The YouTube video includes a quote referencing the actual human engineers building this technology at OpenAI. It says that their day-to-day jobs are fundamentally different than they were just 2 months prior.
2 months is nothing.
2 months. In a traditional corporate timeline, 2 months is barely enough time to get a slide deck approved by a steering committee. Here, the fundamental daily reality of creating the world's most advanced intelligence has been rewritten from scratch in 60 days, entirely because the AI is doing the heavy lifting of building itself.
If we connect this to the bigger picture, we are observing an exponential acceleration of the AI development timeline. Historically, the speed of technological advancement in software has been bottlenecked by human biological limitations.
We need to sleep.
We need to sleep, we need to eat. It's gated by how fast human researchers can type code, analyze dense data sets, run iterative experiments, get a full night's sleep, and synthesize the results over a morning coffee. By integrating an agentic, highly capable AI directly into the core development loop, OpenAI has effectively removed the human speed limit from massive chunks of the engineering process.
There's a huge bottleneck removed.
And this recursive dynamic means that GPT-5.3-Codex was developed significantly faster than GPT-4. But more importantly, it means the successor to 5.3-Codex will be built even faster still because the tools used to engineer it are now exponentially more capable, autonomous, and insightful. It is a compounding interest curve applied directly to the creation of intelligence itself.
Which brings us inevitably to the elephant in the room. When you're dealing with a compounding intelligence curve, and specifically with an AI that possesses a master-level understanding of the deep, hidden, structural layers of software architecture, we have to talk about the double-edged sword. Security and responsibility. The source transcript is very clear that with this level of capability, we must have a serious, sober conversation about it. And the specific domain they highlight to illustrate this risk is cybersecurity. The video throws out another staggering performance metric, maybe the most jarring one in the entire deep dive. This model scores a 77.6% on advanced cybersecurity challenges.
Wow.
They describe these challenges in the video as essentially being high-level hacking competitions.
Yes, these competitions are universally referred to as capture-the-flag events within the global cybersecurity community. They aren't simple multiple-choice tests. They present competitors with highly complex, intentionally vulnerable software systems, networks, and cryptographic protocols.
And the goal is to break in.
The goal is to aggressively probe the system, discover the hidden obscure flaw, and successfully exploit it to retrieve a hidden piece of data, the flag. Achieving a 77.6% success rate against these benchmarks is an extraordinary demonstration of deep software vulnerability comprehension.
Meaning it knows how to find the holes.
It means the model can spot zero-day exploits, memory leaks, and buffer overflows that would take human security researchers weeks to identify. But as you rightly pointed out, this capability is inherently a double-edged sword.
Because attack is defense.
Exactly. The fundamental knowledge required to defend a complex computer network is, atomically, the exact same knowledge required to attack it. To patch a vulnerability, you must first possess the ability to discover how that vulnerability can be exploited in the wild.
Right, you can't fix what you don't know is broken.
You cannot build a perfect impenetrable vault without understanding exactly how a master safecracker would approach the locking mechanism. Therefore, an AI agent with a 77.6% hacking score is, on a purely technical level, equally capable of orchestrating a devastating automated cyber attack as it is of building an impenetrable digital defense.
And OpenAI is clearly aware of this duality, which is why the source says they are tackling the risk profile head-on. The video explicitly states that GPT-5.3-Codex is the very first model officially classified as high capability under OpenAI's internal safety frameworks.
They're treating it differently.
They didn't just throw this massive capability onto the open web and hope the internet plays nice. The transcript details some very specific rigid guardrails that have been implemented before release. First, the model available to the general public is strictly, rigorously trained as a defender. It is heavily fine-tuned to proactively hunt for vulnerabilities, but to completely refuse to write the actual exploit code that would take advantage of them. Second, the system is actively monitored around the clock by automated systems looking for any patterns of misuse or malicious intent from the user.
Constant surveillance.
And third, its absolute most advanced cyber skills, the real heavy artillery, are completely locked down and restricted exclusively to trusted partners, which the video implies are likely government agencies or major enterprise security firms. They are being, to quote the video directly, very, very careful here.
This raises an important question regarding how society structurally balances incredible democratized power with necessary caution. OpenAI's approach of officially classifying this as a high-capability model and tiering the access demonstrates a clear understanding of the asymmetric risk involved.
They know what they built.
They do. However, we must view these guardrails objectively. The measures described in the source training it exclusively to be a defender, relying on automated monitoring, are fundamentally software-level restrictions. And as anyone in the security industry knows, any software system can potentially be bypassed, manipulated, or jailbroken by sufficiently motivated and well-resourced actors.
That's just a matter of time.
Releasing a tool that essentially democratizes high-level cybersecurity capabilities fundamentally alters the threat landscape. On one hand, you are providing millions of small businesses, hospitals, and local governments with an AI agent that can finally secure their networks against sophisticated attacks they could never afford to defend against previously. It is a massive upgrade to global defensive posture.
But on the other hand,
You are placing a tool that intrinsically understands the mechanics of complex exploitation into the broader ecosystem. The decision to lock down the absolute most advanced capabilities behind a wall accessible only to trusted partners is a logical, necessary compromise. But from a structural standpoint, it also solidifies a dynamic where the most potent, world-altering technological tools are tightly controlled by a select few entities.
it's a delicate, precarious balance.
And one that the industry will be navigating for the foreseeable future.
It is a massive societal tightrope, and it is playing out in real time. But as we start to zoom out from the specific benchmarks and the security guardrails and look at the bottom line of everything we've unpacked today, the trajectory is crystal clear.
It really is.
The source transcript summarizes the entire evolution beautifully. What began years ago as a highly specialized, narrow mission to build the world's absolute best autocomplete tool for software engineers has organically morphed into the foundation for something vastly more expansive.
A general collaborator.
It has evolved into a general, agentic collaborator for literally any professional sitting at a computer screen. It is no longer just about generating lines of syntax in Python. It's about utilizing code, utilizing spreadsheets, utilizing presentation software, and seamlessly orchestrating every digital tool at our disposal to manage an entire project, from the initial seed of an idea all the way to a global public launch.
And the ultimate practical consequence of this democratization of capability is scale. Because of tools like GPT-5.3-Codex, the barrier to entry for building complex, highly valuable digital products has been drastically, permanently lowered.
It's open to everyone now.
A single individual with deep domain expertise in their specific field, but zero technical background in computer science, can now architect, build, and deploy enterprise-grade software. A small, nimble startup team of 3 people can now output the volume, quality, and complexity of work that was previously only expected from a massive, well-funded department of 30.
The math completely changes.
The fundamental unit economics of creation have changed. Because of this, drastically more people will be able to build things. And the scale, ambition, and sophistication of the things we can build will increase exponentially. We are stepping into an era of vastly amplified human potential.
Amplified human potential. That is exactly the right framing. And as we wrap up today's deep dive, we want to leave you with the 3 most important takeaways to remember about the real-world impact of this release. First, we are officially moving from AI as a passive tool to AI as an active agentic collaborator that works alongside you in real time. Second, this is no longer just for developers. It is a cross-domain powerhouse capable of handling strategy, marketing, and complex workflows for any professional. And third, the recursive loop of AI building AI is accelerating the pace of development exponentially, bringing unprecedented capabilities and massive security responsibilities directly to our doorsteps.
Those are the crucial points to remember.
And as always, to stay on top of all these rapidly moving developments, be sure to check out the Bite-Sized Tech News TLDR YouTube channel for our daily video updates. We've got you covered on all the latest tech news. But before we go, that brings us to the final thought, a direct challenge pulled straight from the source material that I want to leave ringing in your ears as you go about your day.
Let's hear it.
We've unpacked the paradigm shift to agency. We've discussed the cognitive importance of the speed increase, the hard proof of the benchmarks, the mind-bending reality, the AI feedback loop, and the sobering responsibility of the security guardrails. But all of that incredible technology, all of those clustered GPUs and neural weights are just waiting for a human directive.
It still needs you.
The video ends with a provocative thought, and I want to expand on it slightly and direct it straight to you, the listener. If your computer fundamentally stops being just a dumb tool that waits for your exact, precise commands, if it truly becomes a collaborator, an active, intelligent partner that can anticipate your needs, analyze your flaws, optimize your workflow, and build at the exact speed of your imagination, what does that unlock for you?
A very big question.
Seriously, take a moment today, Look at the screen you work on and ask yourself, with that kind of power sitting right at your fingertips, what will you build? Thank you so much for joining us for this deep dive. It is always a privilege to explore these massive ground-shifting updates with you. Keep questioning, keep learning, and we'll catch you next time.